this question is a fairly standard one about varying the resistance of a part of the circuit to then give you a variable PD output. So the only thing that might catch you out a little bit is this variable PD is an output. That's not the input. So what's actually going into the circuit? The maximum possible voltage available to the whole circuit is 6 volts. And we're then told that the contact moves from C. So the contact C is moved from P to Q. So at P, what's going to happen is that this potential difference is telling me what the difference in potential is between different points in the circuit. Now, if I have it at these 2 points, because they're connected with a wire, there cannot be a potential difference between them, because the wire, we assume, has no resistance, so no work can be done, so no voltage can be lost. So if it's connected up at P, the voltage has to be 0. And if you look at then the opposite extreme, so the opposite extreme is when it's at Q, and we're getting 10/15ths of the 6 volts. So voltages and potential divider circuits, which this is a type of, work on ratios. So we get 10/15ths of the whole is the maximum amount we can have. So 10/15ths, you will hopefully be able to see that will simplify down to 2/3. So 10/15ths is 2/3. So that will drop to 2/3. 2/3 of 6 volts is 4 volts. So we'll go from a minimum of 0 to a maximum of 4 volts. And that will be a linear change. And all the graphs are linear, so that helps us. So we're looking for a graph that goes from 0 up to, because it's going from P to Q, up to 4 volts. And looking at the graphs, move over to the other side, looking at the graphs, that looks to be graph C, going from 0 up to 4 volts.